So now we're moving on to 1.8, which is 3D figures, three-dimensional. And again, there's an awful amount of new vocabulary, different names like face, edge, vertices, prisms. Some of them you know, like pyramid and cylinder and cone and sphere. Regular polyhedron, this is a regular polygon was 2D shape. For a 3D shape, a regular polyhedron is the name for it. And then eventually we're going to go on to surface area and volume. So just like you had perimeter and circumference and area in 1.6, this time you're going to do surface area, so you're going to have 2D shapes in respect, and then volume will be 3D shapes. But again, as you can see at this point here, and then again down here, you've got all the notes that you need to make for your vocabulary. So here we start in example 1, identifying solids. Well, in 3D shapes you identify the solid by the bases or base, and that is its normal 2D shape. It's not what it sits on. In fact, if you look at A, you've actually got what looks like a rectangular prism, but it's obviously, in this case, it's what it's sitting on. But if you look at B, the base of that will be the circles at either end. So the base is the 2D shape rather than where it sits, okay? And again, it's noted by letters of whatever the different shape's been given, and then you're doing the bases, the faces, as the edges, and the vertices are basically points or angles, so they're just single letters. So let's have a look at example 1 in its questions. So let's have a look at what we've got. You've got to determine whether it's a polyhedron. Well, just like a polygon, you've got the circles around here, so the answer is no. That's all you need to do on that. Okay, so let's have a move on question 2. It's solid, it's a solid shape, there's no curves, there's no intersections, so this one is yes. Okay, then you've got to start naming the different parts. Well, the base that it's sitting on, okay, so that's just your L, M, N and K. So that's the base, I'm going to give that a B. The edges is every side, so you're going to have 2 letters here, so let's just start with the base, so that's going to be KL, then we're going to move on to LM, then MN, and then NK. Okay, but that's just the base. Don't forget you've got to go up to the top then, so everything will include J because that's the vertex. So you're going to do KJ, LJ, MJ and NJ, okay, and then obviously the vertices will just be J. There's only one vertices for the top, but don't forget each one of the vertices at the bottom on the base you've got to use as well. So even though J seems to be the only vertices, it isn't. You've still got L, M, N and K. So be careful because it's easy to miss out. So make sure you use all the vertices. Okay, so here's some regular polyhedron. As you know, when you had regular polygons, all the sides, all the angles are equal, etc., etc. Well, you've got the main 5 that we use here. Obviously, a tetrahedron is your triangle. Mainly rings and things like that are the dodecahedron. You know, if you're cutting diamonds, that's a good one to see. And quite often you'll see the octahedron in various shapes. And obviously your cube you use a lot, especially when you're playing board games and you're using a die and things like that. This is the most unusual one, icosahedron. Not very often you see them, okay? So now we're moving on to example 2, which is now going to give us the surface area and the volume. And just like in 1.6 when we were doing circumference and perimeter and area, every time for the surface area you've got the formulas. So again, it's the formula, working and answer. So for each and every one of these, so you've got your 5 regular shapes, and then obviously the volume, all right? And again, when you come to the circular type one, so the cylinder, the cone and the sphere, make sure you read the question whether or not you are using the pi button on your calculator or whether you're going to use 3.14 or whatever number that they give you a degree of accuracy. So all the formulas there, like I say, quote the formula each time you answer a question. You substitute in, so your line of working out, and then answer. The one good thing about this, if you put parentheses in your calculator, most of this you can put in your calculator and it will just give you the answer straight off. So now let's have a look at those formulas, how to use those formulas in example 2. In example 2 you've got a square pyramid. Think of the pyramids of Giza in Egypt and some of the pyramids down in South America. But anyway, let's have a look at what you've got. All right. Now, don't forget, it's a half times the perimeter, and it's the perimeter of the base that we talked about. Okay, and then L is the slope height, and then the area of the base. So if you look at what we've got here, the 24, because the perimeter is 4 times 6. So this guy here is going to be 4 times 6. That's where you get your 24 from. Okay, and then the 5 is the slant height. So the letter L is slant height. Okay, so that's slant height. As against the 4 centimeters in the diagram, that's the perpendicular height. Okay. And then the area of the base, well, don't forget the area of the base going back to 1.6 was the side squared, so that's just going to be 6 squared, which will give you the 36. So that's where they get their information from. Okay, and then obviously again it's all calculator, so a half times 24 times 5. Put that in one parenthesis and then plus the 36 or 6 squared in another parenthesis, and it will do it all for you. Okay, so that will give you an area of 96. And don't forget that's square centimetres, because don't forget area is squared. All right, now the volume is 1/3 of whatever the area of the base is times the perpendicular height. So, and if you look sometimes, well most of the times, between your surface area and your volume, you're going to have the same particular area of a shape. So for instance, in this case, we need the base there, and we also need the base here. So the 36 just comes down. The H, this time H, is the perpendicular height, all right? Or altitude if you're in a plane, okay? So perpendicular height. So again, calculator, 1/3 times 36 times 4, 48, but this time it's cubic centimetres, so make sure you put the right units in. So let's have a look at the questions that fit in example 2. I'm going to go into question number 4. So what have we got? If we go back to that previous pages, what we've got the formulas. We need the surface area and the volume. So if you go back to the formulas, the surface area was 4 times pi r squared. Okay, and then I'm going to change pen colours, and the volume, if you remember rightly, for a sphere is 4/3 pi r cubed. Okay, so you've got the formulas. So again, quote the formulas. All right, the 4 is going to stay there, the pi is going to stay there. The radius in this case is 6, so 6 squared will give you 36. And if you put all that into your calculator, but does it say what it, yeah, that will give you 452.4. And don't forget we're looking at inches, and it's squared this time. Okay, so that's the surface area. Now let's have a look at the volume. The 4/3 stays the same, the pi stays the same, but this time we're going to do 6 squared, 6 cubed I should say. And again, everything there is in a calculator. You can put that straight into your calculator, and that should give you 904. Well, I ran it up to 0.8, and again this time it's inches but cubed. Okay, so what we're doing, this is example 3, real life. This time we've got a noisemaker. As you can see, it's a cylinder in its shape. So again, go straight back to the different shapes and the formulas that you've got. This time the surface area is 2 pi r h plus 2 pi r squared. Okay, so don't forget we've got 2 ends. So we can work out that. And then again, the volume is pi r squared times h, and again it's all number crunching as I call it, so put things into your calculator, put parentheses where you need to put to it, and again use either pi or whatever the question's asking you, but don't forget to read the last part. This time it's to the nearest tenth, so make sure you've got one decimal place. Even if it comes up, if for instance if this one was 60, always put 60.0, don't just leave it at 60 because it's asking for the nearest tenth. Okay, so let's have a look at example 3 and number 5. What have we got? You've got a cone-shaped icing bag. It's 3.5 inches in diameter, so don't forget most of the time, well all the time you're going to be using the radius. So the 3.5 is the diameter, so the radius is going to be 1.75. The 5 inches tall is the perpendicular height, and then the slant height of 5.3. So let's have a look at, I'm just going to do 5A to start off with and leave it at that. Okay, the volume, if you remember rightly, so V equals 1/3 pi r squared h. Okay, so again, put things in parentheses, so you can put the 1/3 pi, you can put that in a parenthesis, that will help you. Don't forget the radius is half of the 3.5, which is 1.75, and you're going to square that, and we know that the height is the perpendicular height, that's going to give you 5. And if you put that into your calculator, you're going to finish up with 16, is that right? Yeah. Okay, so it's 16, but I need it to one decimal place, so it's 16.0 inches cubed. Okay, and then you can do 5B. You can do the surface area. Okay, so 5B, the surface area. I put SA for surface area. It reminds me that I was going to do it. But this time it's going to be pi r and L, and don't forget L is the slope, so this time we need that 5.3, and you're going to add on to that the area of the base. Well, that's a circle, so it's pi r squared. So again, just substituting the different, each of these is the radius, so each one of them needs 1.75 instead of the 3.5. Everything else apart from the L, which is 5.3, a number cruncher, come up with your answer. And you actually get 29.1 if you did it correctly, and that's inches squared, because don't forget that's surface area.